Today, we're going to evaluating functions. And evaluating functions is going to be on page 4 of your notebook, which is the right side of where it's already open. So on page 4, you can write evaluating functions of today's date, August 27th. Okay? Essentially, what evaluating functions are is you are plugging in and you are using Pemdas. So plug in, Pemdas. Plug in, Pemdas is what we are going to kind of summarize it up as to be.
You said evaluating what?
Functions is the title right here. So we're going to summarize it as your steps are. You're going to plug in, and then you're going to use Pemdas. Can you guys tell me what Pemdas stands for?
Parentheses, exponents, multiplication, division, add, subtract.
Perfect. Okay. What order do you work multiplication and division in? Left to right, right? When it comes down to multiplication and division, you work left to right. Same thing for addition and subtraction. You work left to right. Just like you read a book, you read an equation, just the same. Okay? So our steps are, we plug in, we do Pemdas. Okay? On your paper, for problems 1 through 6, you do not have enough room to show your work. So what we're going to use page 4 in your notebook is as where you're going to show the work for those 6 problems. Okay? So you're going to show your work for those 6 problems on page number 4. We're going to work all 6 of them. Got it? Questions, comments, concerns about what's expected on page 4? None? All right. So I'm going to do my imitation of my page because I don't have a real page up here. So this is my page 4 in the notebook. So as I work the problem, I'm going to show my work in that space. If I write something in this box, that means you should be writing it on page 4. Does that make sense? Let me move my box over a little bit. All right, so first step is, again, we plug in and then we Pemdas it, okay? So plugging in, this is called function notation. Sorry. Oh my God. Let's try that again. Function notation. Okay? Simply function notation is saying that you are defining this as an equation based on a given x value, right? So if I have x is in the parentheses, that means I'm plugging in for x. If my value is on the outside, that means I'm plugging in for the f of x, the y, right? So when I look right here, my inside is x, and what is the new x going to be? 16. So where x is in my problem, I'm plugging in 16. So I'm going to have 3/2 times 16 minus 5. 3/2 times 16 minus 5. Okay? When we do this, your quiz in test, you will not have a calculator. So if you are relying on your calculator for this, please do not do so. You will have to show your work to receive credit because we are learning how to break away from the calculator. Okay? So things to remember. When you have a fraction, can someone tell me what a fraction stands for? What does a fraction represent? What operation?
Divide.
Okay? Which part of the fraction represents divide? No, not the bar. Huh? So with a fraction, your denominator is what you're dividing by, and your numerator is what you are multiplying by. Most of you are unaware of this because you just do control divide and type in the fraction as a whole in your calculator. But there's a mathematical reasoning why the calculator spits out an answer. Your numerator is what you're multiplying by. Your denominator is what you are dividing by. Which order you go in does not matter. It is totally up to you. If you're a person who likes to multiply large numbers, then multiply first, then divide. However, I'm a person who likes to make small then big. Does that make sense? I would rather divide you if I can and then multiply. So when I work this out, I have 3/2 times 16 minus 5. So I'm going to divide by 2 first. What is 16 divided by 2? 8. So I'm left with 3 times 8 minus 5 because I did the division of the 2. Does that make sense? Your denominator is what you divide by. So this is what you should be writing on page 4 in your notes. So now I'm going to multiply because I have multiplication. What is 3 times 8? 24. So now I'm left with 24 minus 5. And my last is adding and subtracting, which means combine like terms. And 24 minus 5 is 19. So my final answer is 19. What are your questions? What does a fraction represent again? Multiplication and division. The numerator is your multiplication. The denominator is your division. Okay? Can we try again? Want to try again? We're going to survive? I think we will. Alright. So I'm going to do number 2. So number 2, it says that I'm substituting in negative 9, right? So I'm going to substitute a negative 9. So I have 3 halves times negative 9 minus 5. Okay? Right off the bat, I know that does negative 9 evenly divide into 2? No. So I'm not going to start there. Instead of dividing first, I'm going to multiply. So I have 3 halves times 2 times negative 9 minus 5. 3 times negative 9 is?
Negative 27.
Negative 27. And negative 27 divided by 2. So now I'm down to division. What is 27 divided by 2? 13.5. But it's negative, so it's going to be a negative 13.5. Okay? Last step is to combine like terms. If you already owe me $13.50, you're like, hey, let me hold another $5. How much do you owe me now? Negative 18.5. Because you owe me money, right? Okay? How do we feel about fractions by hand? Was it that terrible? Because you all can multiply and divide. You just got to stop seeing the fraction as its own thing. Okay? It's not. It's just the mathematician's lazy way of writing a multiplication and division problem. Question? Comment? Okay, so if you look at example 1 is more like a algebra 1 at the end of the year problem you would get. If you look at example 2, we now have something that didn't come out so pretty, and we had to utilize a decimal. So it's like a beginning of an algebra 2 problem. So we've gone algebra 1, algebra 2, now we're going to do beginning of a pre-cal problem, okay? So when we look at example 3, that's our pre-cal problem. So let's give that a try. Okay, so this time I'm substituting in a whole expression, right? It's not just one number, it's an expression that I'm substituting in. So I'm substituting in 2a minus 6. So I have 3 halves times 2a minus 6 minus 5. So when I work this out in my notebook, I've plugged in, so now I'm going to go through the stages of Pemdas. Does my parentheses look already simplified? Can I combine any like terms in my parentheses? No, it's good to go, right? Are there any exponents for me to be worried about? Nope. Is there multiplication that can take place? Yes. Remember, parentheses is implied multiplication. Okay? Can anyone tell me what that process is called? There we go. We're going to use our distributive property. So our distributive property, I call it climbing the mountains. You got to climb the first mountain, woo. You climb your second mountain, dang. Okay? So I end up with 3 halves times 2a minus 3 halves times 6 minus 5. So we're still going through our Pemdas. Is there more multiplication and or division that takes place? before I can combine. Yeah, right? So again, what does a fraction mean I'm doing? Multiplying and dividing. So I'm multiplying my numerator and dividing my denominator. Doesn't matter on the order. No, it's just a personal preference. So if I did 3 times 2, that gives me, and 6 divided by 2 is, so this becomes 3a. On this one, I was like, you know what? I want to divide first. So 6 divided by 2 is, and 3 times 3 is, again, you can choose whether you're going to multiply or divide first. Multiply or divide first. Okay? Any more multiplication or division that needs to take place? We're good to go? So now we're on to adding and subtracting. Remember, adding and subtracting just simply means combine like terms. So I'm going to combine my like terms. And in this case, my like terms are the -9 and the -5. So if you owe me $9 and you're like, hey, let me get another 5. You now owe me -14. So my final answer is 3a minus 14. How do you feel? Doable? Yes. I think so. I think you can do it. All right, good. Because you're going to do examples 4 and 5. So you're going to do examples 4 and 5, my precious friends. So if you look at 4 and 5, my hint for you for 4 and 5 is to be mindful of order of Pemdas. Okay? Be mindful. So your function notation is a little different. Your function notation is C and M, right? It doesn't matter. It's the same thing as it being f of x. The function notation is the same. But this time, instead of substituting in for x's, you're substituting in for m's. All right? Okay. I'm going to give you about 5 minutes or so. Let's see how that goes. Okay, so how do we do? Did y'all check with each other? It couldn't be horrible. I feel like y'all are dramatic. I feel like you're being dramatic. All right, so on the first one, the work you should have shown. Oh, crud. Is for the m, what value did I substitute in? 4. So for m, I'm substituting in 4. So I have 2 times 4 squared minus 3 times 4. Pemdas tells me I do my exponents first, right? So 4 squared is 16. And 2 times 16 is 32. 32 minus 12 equals 20. So we should have gotten 20 for number 4. Okay? Be careful with your negatives, guys. On number 5, you have 2 times -6 squared minus 3 times -6. A negative times a negative is a positive. So I end up with 2 times positive 36 plus 18, because a negative and a negative makes a 18 through multiplication and division only. Besides that, 2 times 36 is 72. And 72 plus 18 is 90.
Oh, I got this.
How do we do on 4 and 5? Okay, so we moved a little bit more. Now we're going to do a little more of a pre-cal problem with b minus 2. So we're going to work that one together. This is the last problem you have to work in your notebook. Oh, why did you tell me that before I erased? Oh, you gotta say something. I've erased it. We'll stay after class. Alright, so b minus 2 is my expression that I'm substituting in. Okay? What we need to recall here is that when you have a squared expression, it actually means you have how many of them? There's 2 of them. Okay? That means there's 2 of them. So it's not just distribute the square, you have to write the whole expression twice. So I have now 2 times b minus 2 times b minus 2 minus 3 times b minus 2. Be picky. You know it's 2. You heard me say 2. And I don't know why. I refuse to write my 2's all the same when I write them. I can't. I don't know what's wrong with my mental block. So what we're going to have to use here is FOIL. Do you guys recall FOIL? Yes. FOIL is our first, outside, inside, last. And so it's the terms that we multiply together. So my 2, I'm going to hold off to the end. And I'm going to do FOIL. So my first 2 terms together, what's b times b?
B squared.
B squared. On my outside terms, so b times negative 2, and what's b times negative 2?
Negative 2b.
Negative 2b. And then my inside terms, another negative 2b. And then my last 2 terms. So a negative 2 times a negative 2 makes a
Positive 4.
positive 4. Okay, and then I'm going to distribute my negative 3. That gives me negative 3b. And then negative 3 times negative 2 is positive 6, right? I'm almost done with distribution, but I still have this guy. So I need to distribute this 2. What's 2 times b squared?
2b squared.
2b squared. 2 times negative 2b?
4b.
How's that what we're looking for? Negative 4b. Again, another negative 4b. And 2 times 8? And 2 times 4?
8.
That's what I said. My bad. And then plus 6. Is there any other multiplication or division that needs to take place? No! So we're down to the combining like terms. So, does 2b squared have a friend? Nope. So it stands alone. I have negative 4b, negative 4b, negative 3b. What does that make? You combine them all. So 4, 4, and 3 makes
Negative 11.
a negative 11b. And then I'm left with 8 and 6. So what's 8 plus 6? 14. So my final answer is 2b squared minus 11b plus 14. And that is your final answer for that one. What are your questions? Okay, so when we have a quiz, and this is on there, show your work, guys. I will give you partial credit. But if you don't show me any work, can I give you any credit for trying? Because I can see, oh, he just forgot to add the 6 and the 8. But you have it there. So I'm not going to count it fully wrong because you knew what you were doing. You just made a little mistake. Does that make sense? So please, please, please show your work. So on your quiz on Wednesday, there's going to be over domain and range and evaluating functions. So if you are struggling with this part of evaluating functions, please, 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 please remind me so that you can come to tutorials and get the help you need. Okay? All right. So let's get to the easy part. I'm sure you all are ready for that. I like to do the hard part first, and then you'll appreciate the easy. It's my logic. I don't know if it makes sense to most people, but. All right, tables. Tables are, I will tell you, I will be thoroughly disappointed if you get a table question wrong. Okay? Because it's like playing I Spy. That is how tables and graphs work. You are playing I Spy. So, remember this is function notation. The inside of the parentheses represents the what value? The x. So if this says R3, that means I'm looking for when x equals 3. So I'm trying to find when x equals 3. I go to the table like, oh, look at that. And what do I get when x equals 3? 2. That is it. Do you see why I would be disappointed if you got this wrong? Okay, so let's try number 8. So if I look at 8, this time I'm looking for 5. So I'm going to go to my x value, find 5, and what do I get? 5. Whew. That was a booger. That was tough right there. Okay? Alright. So if inside the parentheses is x, what does it mean if I'm on the other side of the equal sign? I'm looking for, if inside is x, what would the outside have to be? The y. So this one means I'm looking for my y. So I'm looking for when does y equal 1. So I'm going to this time go to y, go down. Oh, when does it equal 1? At x equals 4. Oh, there's another one. Here's a 1. And where does that take place at? X equals 6. Whew. Struggle. Okay? I would like for you to do 10, 11, and 12. So do examples 10 and 11, 10, 11, and 12. I'm not even going to give you like a whole 2 minutes. I'm going to give you a minute and a half to do that. If I can set the thingy. There, I set it. It's been hot, so we're making progress. All right, so what do we get for 10? When it's h is 0? 2. Good job. What's h of negative 3? Woo, 5. So hard. Did y'all break a sweat? No. What is h of d equals 1? When does that happen?
No solution.
No solution. It's undefined. It never happens because it's not on my table.
Your phone is ringing.
I hear it. All right. So the same thing you did on the table is what you're going to do on the graph. Hello? Yes, ma'am. I was. I am.
So is it 2?
Okay. F of 4. What'd you get?
2.
Perfect. Easy enough? So you go to 4, because remember this is your x. So you go to x, go to 4, and go up, and what do you get? If I need negative 1, go to negative 1, go up, and I get? Good job. If I need negative 2, 2. My body's in the way, my bad. So I went to negative 2, go up. Perfect. If I go to 0, what do I get? 8.5. Perfect. Okay, what if I want negative 1?
There's definitely not get it.
So this one is on the y, right? So that means I'm going to go to the y, and then I'm going to go over until I hit negative 1. And when do I hit negative 1? It looks like negative 2.5. It won't let me circle it, but we're going to, it's somewhere in there, okay? So I know that x equals about approximately negative 2.5. Okay, well what if I want to know when y is 5? So I'm going to go to 5, and how many times do I have 5?
2.
I have it 3. I have it 1, 2, 3. And so you write all 3 x values. Okay, so this one is like negative 1.5-ish. Will we agree with that? And then this one is it at 2? X 2. And then our last one is where? 5.5? Approximately 5.5. So do you guys see how easy tables and graphs are? We shouldn't get those wrong, right? No?
We get out of here 3 days, right?
Yep. All right. So we accomplished our job for the day. Y'all are the only class that we made it all the way through the front page. Good job. No, guys, hold on to it in your folder. We're going to resume the back. Thank you for a great day.